Okay, I'm back. So I was before I got interrupted. I was talking about the data set I've created here in Kaggle. So I've created a data set for my Raspberry Pi camera because my garden is actually I'm quite lucky, right? In my garden I have a lot of wildlife coming, but very limited, right? I don't have bears coming, thankfully. I have like foxes, cats, and birds, right? That's good enough for me. Maybe I have more things. I don't even know, right? One day I'll find out. Who knows? Anyway, so I've created a data set here. For now, I only have three classes here: bird, cat, and fox. But I'm going to add two more. One for people, which I want to ignore. So but I still need to detect it. Then for anything else, other, and other, I'm going to use mainly for when my garden is like empty. There's nothing there to see. So I want to also capture that so that I can decide to ignore those type of events. Right, I think you can hear me, right? Okay. Anyways, so let me just give you an overview of what I've already done in my notebook. Right now it's private, okay, but I'm going to make it public after sometime today or tomorrow. And I've already spent a few days working on this notebook, and I used the Tensorflow website, which is a very good resource, I would say. But you have to be careful with what tutorials you find. I'll explain that in a second. So there is a tutorial on transfer learning, because I'm doing transfer learning. I'm not going to train my own model from scratch. I'm going to take a model like the ImageNet. For now, it's the ImageNet, and I'm going to train that. Well, with transfer learning, you basically take the last layer of the model and replace that layer with your own layer. And here there is a good guide. To be honest, I normally just search for what I want, so I don't even know where to get it. If I go directly from the TensorFlow website, I don't know how to get to the tutorial. Okay, so there's two tutorials on transfer learning here, and there's one with TensorFlow Hub. This is just using just demonstrate how you can download a model from the TensorFlow Hub, and you can remove the last layer easily. It makes it very easy. It downloads it automatically, and you're good to go. Anyway, I started with this tutorial. I modified it to work with my dataset, and I found the results were really bad, and I was a bit confused because, okay, I started with 100 images in each class. Then that the results were horrible. It was detecting everything as cats. And then I tried to increase the number, but I still got really bad results. I still don't know exactly what's wrong with this tutorial. Maybe there was something that I was doing wrong. But anyway, I swapped to this tutorial here, transfer learning and fine tuning, and this works. Okay. And in fact, I'm getting really good results, which is quite amazing. Anyway, these first three blocks, these are only needed if you are running these outside Kaggle, okay? So for Kaggle, you only need to run it from this section, okay? You can see already, my notebook already has the dataset that I'm going to use. This is using the dataset I uploaded to Kaggle as well, version 3. And the nice thing about Kaggle is that you don't have to do any of these. You don't have to download the dataset from the zip file. You basically just say, okay, I want to use this dataset, and you can add it to your notebook easily, okay? Okay, what I'm going to do, Okay, I have quite a random number of pictures here. So I have, for example, I have almost 4,000 birds. I have about almost 4,000 cats, but for foxes, I only have like just under 500 foxes. Okay, so the problem I have is if I take the whole data, right, I'm going to have an imbalance from the very beginning. Okay, and I don't want that, because I want to make sure, I want to control exactly how much data I want to use. There's no like hard and fast rule, but normally it's a good idea to start with a balance. So in each class, you should have more or less the same number of pictures, right? So if you decide to go with 100, then you should try to get 100 pictures from a bird, 100 cats, 100 pictures of a cat, and so on, right? So that's why. Before, there was something in the TensorFlow API that allowed me to control how much data I want to get. But now, for whatever reason, they deprecated that API. So I spent a few hours already like trying to find out how to make this API work, but it seems like they've removed it. So what I ended up doing, I created this method here. So I created this method, and this method basically goes through each folder in the dataset, for example, birds, cats, and it basically takes the number of samples that I'm looking for. So in this case, I have a default of 1,000. Okay. So, but in fact, I should have this something like just under 500. Okay. So when I run the notebook, so the first, this cell is just to read the method into memory, so you can use it. By the way, it takes some time to load at the first time. That's why it's waiting. So you can see, I'm actually already using a GPU. Okay, I have a syntax error. Might have added this by mistake. Let's try again. Okay, it was just some syntax. Make sure you also run this cell for the imports. So I'm using a GPU. You can decide what to use. Without a GPU, you can run as much. You can use this notebook as for as long as you want. If you use a GPU on Kaggle, you have like a limited number of hours. I've already used like 6 hours of my GPU. You don't necessarily need it. I think you might be able to run this without a GPU actually, because it's quite it's not a lot of data, and we are just doing transfer learning. Obviously, we are using Python. This is a monthly quota. Oh, I can even schedule this. Awesome. Right, so I'm going to run this method now, and this is going to take samples from each data set and the equal number of like photos from each class. Okay, so in this case, now I know that I have a balanced data set from the start, which is quite important. Okay. All right, and I have here this cell that just allows me to check how many pictures I have in each folder. We have 500 birds, 500 cats, and 475 foxes. Okay, maybe I should have picked a lower number, by like 500 anyway. But it should be okay like this. It's more or less similar. Okay. So what I'm going to do now, I'm going to keep running the notebook. And this is just this code is just basic to view some of the photos we have in our data set. You see a fox, it's quite tiny actually. By the way, one of the things that happened because of the way I collected this data set, not all the images have the same size because they come from different sources, right? But it doesn't matter too much. It shouldn't be a big issue because we are going to resize all the images to the same size depending on the model that we use. So we have birds and we have cats. Okay, so for now we have 3 classes, and these are all data sets that I've captured from the internet. And I don't have a test data set yet because I'm collecting one, and I'm actually planning to do that tonight. I have some videos that I've taken from my Raspberry Pi camera, and I need to extract from that video some photos that I can use for my test data set. Right now, I'm just doing a very basic, everything manual kind of workflow, so I'm not relying on any software. In the past, I did have a video which showed you how to use CVAT, which is a software that many like data scientists use to basically allows you to annotate data directly from video files. And if you have a lot of data, honestly, that's probably the best way to do it. But if you're just doing it for fun, it's okay to do it in a ad hoc way. But I still have a way to make it faster because I don't like to waste too much time. So this method, it's a TensorFlow method. It's very useful. This method loads all the images from the directories that we picked. Okay. And it puts them, so the train directory is the directory that I've picked, I've already specified somewhere at the top. Okay. So this loads all the images into this data structure. Not everything gets loaded straight away from disk, but it basically gets added in batches, right? So you can see the batch size here, 32. So the image dataset from directory will load images from the training folder with a batch size of 32, which means that each step, when we are training the model, at each step it will take 32 images, put them into memory, and then we'll process them. Okay, the batch size. The image size here, this is going to be 224 pixels a square. And then we have here something very useful, and that's why we use this method. Crop aspect to ratio, because we are getting random images from the internet, and they have different sizes, right? And different aspect ratios. So what we want to do, we want to square everything, but we don't want to distort the images. So we have here this property called crop aspect ratio. Is set to true. So that means it will it'll do a center crop, right? It will center a square in the image and then throw away anything that's outside that square. Okay, so let me just run this. This is just an example on how to run this. I'm actually running this code again below. Boom. One thing you'll notice if you run TensorFlow, there's a lot of warnings like this. In fact, they look like errors, but actually these are probably just more relevant information for whoever is developing TensorFlow. Often you don't have to worry about this. So I'm going to ignore those error messages. Okay, so here, what we're doing, we just, instead of just viewing one of the images in our data set, we are doing using that, we've just loaded, we've just talked about image data set from directory. This takes takes images in batches with a batch size of 32. And then here we can just view some of the images that we have. So it loads the image and then also gives you the label. So you can see our data set here. This is the ground truth, okay? So we expect everything here to be correct. But you never know. When you have like thousands of images, you might have some mislabeled data, and that's something, to be honest, to be expected. And that's why there is an exercise in data science to remove outliers to make sure that, because your data will always have some bad data. That's the first rule of thumb. You have to make sure you find your outliers and you remove them, because otherwise you end up having a situation where your data, you might get the wrong results because of your outliers. Okay, but I don't expect this to have too many issues. And here, this cell is only to just check our shapes. Make sure that 32 is the batch size, 224 by 224, that's the pixel size. That's each image that we're going to fit to our model is going to have this size. So some of the images in our data set, actually, they probably have more than that in terms of resolution, but some might have less. And if they have less, then we're going to upscale them. That might not be a great thing to do, but, you know, then we have to do what we have to do. Right, so now, okay, this is where we actually start loading the data properly. And you can see here some more properties. Shuffle, just to mix everything up. We've already talked about batch size and image size, and crop to aspect ratio. We already know what that does. And then there is this property here, which is called validation split. And what this allows me to do is that, okay, for training a machine learning model, you need to have at least a training data set and a validation data set, okay? And you probably noticed that I don't have a split here. Everything is in the same place. And it's on purpose, because I don't want to commit myself yet to any split in the training data. So I'm going to, using this very useful method in TensorFlow, I'm going to do a validation split. What that means is that 80%, well, 0.2, yeah, so 80% of my data, of my images, are going to be used for the training, right? This is trained data set. And then the remainder, the 20%, will be for the validation. So here, in this method, we say subset. I'm trying to pick the data for training, so I have to say here, subset equal to training, okay? This value here is referring to the validation data set, which I'm not like really specifying the validation data set here, but that's how it works, right? You specify your validation split, okay? So if I say subset equal to training, then it's going to take 80% of the images in the training directory and it's going to use it for training. And we have here this seed number. It's very important, this seed number, because it needs to match what comes next here. So because here in the cell below, I'm trying to pick my validation data set, okay? If I don't use the same seed number, this is not going to, it's going to have some common images with the previous data set, right? So if I use a seed number, then it will know, okay, I've already picked all the images for the training. I'm going to use all the remainder of the images for the validation, right? So we will not repeat any photos in the two data sets, right? It's going to be a proper split. So you need to make sure you use the same seed number. And then the subset, you need to call it validation, of course. Right. Okay, so that's what we have. In this cell here, we are just picking what is the classifier model that we're using. We are using mobile net for now. That's actually better for the Raspberry Pi. We're not using the whole model. We're going to use the bottleneck of the model. And the bottleneck means that I'm not actually taking the last layer at least of the model. I'm going to drop that. And with Keras, it's very easy to do. So I don't need this cell anymore. I used to. Okay, I'm going to delete this for now. So here we are also specifying that we want to do some data augmentation. I need to pay more attention to this later. For now, I only have a very simple data augmentation. Flips, basically, I'm flipping the image horizontally. And then I'm also doing a rotation of the image. Not too much. It's just like a little bit random rotations, but 20%, 20 degrees. This is important because we are increasing, instead of just having 500 images, we have a lot more because we are varying the data. And yeah, because we also want to make sure to make it more difficult for our machine learning model to cheat, because in the machine learning model will try to cheat, right? It will try to pick things that are not necessarily in the subject that you're trying to identify, to use it as a way to identify it. So by adding variation in images, then you prevent the machine learning model from memorizing the wrong things. Okay, so we have. So what we're doing here, we're using the mobile net. We're not including the top layer. So the top layer is the one that actually, because mobile net actually can identify 1,000 classes. So the model we want to train today is only for 3 classes for now. So we're going to remove the top layer, okay, and we're going to use the images, the weights from ImageNet. Okay. And we are also saying here that we don't want to, the base model itself, we don't want to train it, so we're going to fix all the weights. And the idea is we're going to add new layers on top of this model, which will contain, for example, the classes that we want to identify, like the cat, dog, and the cat, fox, and bird, right? And we only want to adjust the weights for those the new layers that we're adding. Okay. So here, this is taken from the TensorFlow tutorial. It's doing a global average pooling. It's basically because when you actually take the top layer from the mobile net model, you get something like, it's almost like a cube of features, and there are 1,280 features, and then it is like 7 times 7 times 1,280, so it's like a cube. And then with average pooling, let's just do just see what that is. But I think it's important. Some random. Just wanted to show you. Basically, we're reducing the number of parameters that we want to connect. At each step in the model, right, you have more and more parameters, more and more weights. And then global average pooling is basically just simplifying the model. And in this case, we're using that global average pooling just before we add the dense layer, which this dense layer is like basically 3 neurons. And 1 neuron each is for the classification that you want to, the classification label you want to identify. In this case, we have cat, a fox, and a bird, right? Okay, this is what it is. There's something else that we are actually adding here besides the global average pooling and the dense layer. There's also a dropout, and this is a regularization. This is needed to make sure. Basically, we are trying to confuse the model a little bit. You might be asking, why do we want to confuse the model? We want to confuse the model because we want to make sure that the model doesn't just go the easy way to learn like the features that it needs to identify. Because you're trying to tell it, okay, I want you to learn how to identify foxes, birds, and cats, right? And then many times the machine learning model, when you're training it, it's going to go the easy way. And the easy way is basically going to use things that you have in your photos that are common across those photos by coincidence. And it's going to use that to identify cats and dogs and whatever, right? But to make it harder for the model to use those bad, I would say, to make it harder for the model to use the wrong features, we're doing a dropout. And the dropout is basically randomly pruning certain parts of the machine learning model. So basically, we take some neurons away. It's a bit complicated, but regularization is actually very important. And it basically helps you. It helps the machine learning model also not to overfit into your data set. Overfitting, when you basically train a model, and if you do overfitting, the training is going to work very well for the data set you trained on. But if you try to give it an image of something which is outside your data set, it's going to be completely wrong, because it basically memorized it. It didn't understand. Instead of like understanding what is actually a fox, a cat, and a dog, it just memorized everything. So that's why we don't want, in general, to overfit the model. And we use regularization dropouts to basically prevent it from doing that, making it hard. Okay. All right, so we have run this cell, and now we have here we are going to compile the model. We're using our optimizer is Atom. It's you can use different optimizers. And the learning rate is how fast we want to shift our weights each time that we go through our machine learning, each time we're training our model. And then the loss is basically, this is important, okay? The loss function is what we use to, is an indicator basically that whether we are improving or if our model is getting better or worse, right? So this loss should go close to 0 when it's getting closer to the actual results, right? When it's getting everything right, okay? So the loss should go down and the accuracy should go close to 100, okay? 100%. But then there's also, you need to know how many things you're trying to identify. In this case, we are trying to identify 3 categories, okay? So we need to use sparse categorical cross entropy. That's our function. If we were trying to identify only 2 categories, like true or false, that case, binary cross entropy, it would be the thing you pick here. Okay. So I'm going to run that. And now we're just going to see how many variables we have in our model. Basically, this means we are learning weights and what else? Something else, I forgot. We can see what our training variables are, actually. All right, so let's do this. Oh, it's not. It's looking for something it can't find. Let me see. I'm sure I run this. That's strange. What happened there? Okay, so this cell, it's actually, we haven't trained the model yet. We just want to see for a model without, okay, we've added a new layer to the model, right? The tense layer, right? We haven't done any training, which means that weights are like just default weights there. And we just want to see what the accuracy we get here. Of course, we expect to have a very low accuracy and a high loss because we haven't trained anything yet. Okay. And I'm just doing evaluation right now with the validation dataset. Later, I'll change this to use the test dataset. But anyway, this is before training. And now, let's train it. Supposed to do something. Okay. So now we have 10 epochs. And it is quite quick, actually. So we expect the loss to go down and the accuracy to go up. Hi, Narendra. Sorry, I just noticed you're there. Yeah, I have to. Yeah, I understand you want to see more videos on 2D to 3D, but I need to also prepare for that. But I haven't forgotten it. Thanks for mentioning it. Right. Okay, so the model has completed the training, and we can see now that we have, I think our validation loss is still quite high. We can actually continue training this. No, is it? Yeah, it's quite high, right? Yeah, 10% loss. Okay. Anyway, let's see what results we get with this, only with 10 epochs. So this is going to, here we can see our results. We can see we have cat, bird, fox, cat, fox, cat. yeah, it seems to be completely right. So I need to clean up this code here. So just to explain how this works. So the model, when you call basically we are evaluating our results by calling predict on batch. Okay, so I pass in image batch from our validation data set. Okay, this gives me a list of predictions. Okay, if I show you, so it looks like this, yeah, the predictions. Okay, these are logits, and then we apply this function here. We apply a function tf.math.argmax. So for each element in our array, okay, each element has 3 numbers, yeah. So what we are going to do, so each element has 3 numbers, and each number corresponds to the class that we're trying to identify in order, right? So I think this is depending on, well, the class names, we can find out what the order is, but so if I print this, so print class names, you see, so the class names that we have is bird, cat, and fox, right? So I think this one is bird, this is cat, and this is fox. Okay, so we have all these numbers, right? And what we want to do, we want to pick the highest number for each element. Okay, and that's our prediction. In this case, just looking at this, it should be a fox. Okay, so the first one is a fox, and you can see it's a fox here, right? So the second one should be a bird, right? Yeah, a bird. You see, that's how it works. I have to say these results are pretty good for a first go, right? But it took me a long time to get here because I spent like days trying to get this to work, and I was using the wrong code, and I wasn't sure why it wasn't getting the right results. But anyway, it's all working great now. But it took time to get here, so don't be disappointed when you don't get the results you want at the first go, because that's not normal anyway. Okay, so this function, this is a mathematical function for TensorFlow, tf.math.argmax. Basically, it takes a list of elements, in this case, this list, and it will return the index of the highest one. So in this case, it will return, for this one, it will be returning 0. For this one, it will return 2, 0, 1, 2, yeah, and so on, right? So you can see here, the result of applying tf.math.argmax gives me an array of just indices, yeah? And then using this NumPy magic, right? I can convert that array of indices to an array of class names, okay? And that's where we get our predictions here. And then we using matplotlib, which is a very useful library that everyone in data science uses. That you can just create a grid of all with the predictions that you can easily display, and it's always good to do a visual check of your results to make sure that there's nothing funny going on. I can actually make this a bit bigger, right? I can make it 40 by 40. Yeah. so you can see all the nice images that we have. Okay, so I've just run the notebook once, and I'm going to make sure this is public. I need to tidy this up. I'm going to add some nice context and explain what I'm doing here, but because I want you to also try it, right? If you watch this video, you can go and try it, even if I haven't really made it completely available. So I'm going to just change this to version 1. And can I make this public? I'll try to make this. Anyway, I'll make it public later. Okay, so this is what I have. And what I need to do next, I need to, so I have here some videos from my garden. Okay, you can see. Okay, so this is, okay, see, I have a fox here. So what I want to do, I'm going to use VLC. It's a software that, it's a free software actually. And there's a function in VLC. Okay, I could write a Python script to do this as well, but I don't feel like doing that now. But with VLC, you can just extract all of these frames from the video into a folder, and it will create an image for each frame. And then what I'll do, I'll just take a bunch of frames with foxes and with birds and with cats or whatever, and then I'll create my test data set like that. I'll probably have more images on the test data set than on my other data sets, but yeah, I can use it later if I find it relevant for the validation data set. But I think my first choice right now is to make sure that I only use my own images for the test data set, so that the model doesn't have any like dependency on my garden. Yeah. So let's see how to do that. So I'm going to open VLC. Okay, so I go to, the way I have to do this, there's like a filter for a video. It's called a scene filter. Yeah. So what I can do, basically, I can specify the image format. PNG is fine. I don't care about the width and the height, you know, because I already have a code that can make it specific. So I will start with, okay, I can start with foxes, why not? Because we don't have enough foxes anyway. So I'm going to create images with a file name prefix of fox, okay? And then here I can specify the recording ratio, and this is, I see. So basically it means the lower the number, the more frequently it will create images. So I want to create, so 1 out of 10 images is going to be recorded if I have this number here. So if I have a video with the 20 frames per second, it's going to do 2 pictures per second, roughly. I think the Raspberry Pi is 20 frames per second, but I'm not sure. Anyway, maybe I can do 20. And if it's too less, then I can make it a bit lower. Okay, so now, oh, let me just go back to this. I want to know which folder it's going to. Sorry if I'm not going to be always speaking, you know, because unless I have something useful to say, or if you have any question, let me know, I'll answer. See the filter. directory path. I need to make sure I change this. I'm going to create a temporary directory. Dataset. Okay, so let's see. So now I'm going to view the video again, and it should create me the files. I lost okay, I was just opening directed from here. So I'm going to jump. Okay. So you see from here, okay, I'll stop here now. Didn't create anything yet. Something went wrong. Okay, I don't think I enabled it. So I need to enable it. Scene filter. What? Okay, here. So save. So now okay, let's do that now. So if I play, it should hopefully work now. Let me see. Nothing yet? Okay, it's creating it. But I want to jump to the place where the fox is actually showing up, because otherwise it's just a waste of space and time. Okay, so now I can see the fox. Yeah, and I can stop now. All right, so I have a fox. I have more, so I'll do a couple more videos. But first I need to remove the stuff that is empty. I need a better view. Like this. Like this. Okay, this is better. So I'll delete all this stuff. Okay, I already have a fox there. Okay. This one is empty. Delete. Delete. I don't think I want to use this one, so I'm going to delete it. I want to have the whole fox. I want to have the whole fox, so there is no doubt. Okay, this is okay. This is okay. No, why can you? This is okay, this is okay, this is okay, this is okay. Yes, 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 yes. Yes, yes, yes. So it's good. So I have some images already. Let me find another video. I'm going to pick first, not use VLC for, I want to see what's coming first before I do another one. Okay, I've already done this one. Okay, I'm going to pick another resolution because that was using an older lens that I had, which is good for seeing things far away, but it's a bit narrow, so I have this wider lens now, which is more wider, and that's so I want to take some photos from here. So open with VLC. So I'm going to go straight to the section where the fox is. Oh, there's two. Nice. So I don't mind, it's okay to have two foxes. The only trouble you might get is when you have in the same image more than just a fox. Maybe you have a cat, a dog, and a fox in the same place. I bet the model will be a bit confused by that. Okay, so let's see what images we have now. It didn't do any. I thought it was. Oh, maybe I didn't use VLC. Okay. Okay, so we have here. Should be creating more images. I wonder if it's going to overwrite. I hope not. Seems like I have to pick it again. Save. Okay. So now I should be creating images. I hope. I'm not sure. It's not really creating more images, and I wonder it's because it already has files there, so maybe I should just pick another folder. This might be easier for sorting. Temp. So I'm going to create a temporary directory. Right, so temp. It's not doing it yet. Okay, it's creating now. I'm going to stop it because I don't want, I just realized the file names are are similar to the ones I had before, and I don't want to have any problems once I put everything inside the same folder. So I'm going to change here the settings for the name. So video. Fox 2. Okay. All right, so I have a temporary directory. I'm going to delete everything here again. And I'm going to start again. The play button, but not from the very beginning, obviously. Okay. So I'm capturing more images of foxes, and I think I will not need any more than this for foxes. This is just for the test data set anyway. I'm not worried about variety. I just want to make sure at least I can identify a fox in my garden. Or 2. I've seen 3 or 4 actually. Okay, fine. So now it's done. Make sure extra large icons. So I can delete the images that have nothing. And only leave the fox. Yeah? Fox. Fox. This one doesn't have a fox, or it's not visible, so I'm going to delete it. Awesome. Okay, so fox here. Fox here, fox here, fox here. Every image has a fox. Or more than one. Cool. This one is a bit cut off. Can be a bit ambiguous. I don't think I need it. Less is better sometimes. Although it shouldn't have any problems. But I don't need too many. So in this case, I don't want to include any fox which is half in the frame. But it's not really, it shouldn't be too much of a problem even if I did, since I'm not using this for training. Okay, so now I'm going to just move this to the foxes folder. Now I've plenty of foxes, yeah? Right, so let me just pick another test class. So I have birds as well. Can I identify this bird? Hopefully I can. You see, I even have a bird flying. Awesome. Okay, so I'm going to open this with, no, first of all, I need to open VLC. I need to change the file name. Okay. And now I have some pictures of birds. Awesome. Okay, so let's see how many I have now. So I need to do it, the ones that have nothing there. Okay, I can do it this. Okay, so now I have, all the frames should have a bird. Right, awesome. So now I'm going to move them from here. And I'll create a new folder called bird. This is test dataset, so I don't need to come up with a collection of all types of birds in the universe, because it doesn't matter. I know I have more than one type of bird, but this is why I'm not too picky with the test dataset. I know it's not too important. It's a good way to understand if your model is actually doing the job that it's required to do. But other than that, it's don't need to worry about it. Okay, so let's see what other types of birds we have. Okay, we have tiny birds, which I don't think it's, I don't really care, to be honest. Ooh, I had once a hawk like in my roof, and I have a picture of him. If I had a hawk come to my garden, I would want to know about it. But you know, tiny birds. Okay, we have here this bird that just flew past, right? You know this. You can see it, right? Yeah. I think I'm going to. I know. I don't think I want to do this one. Pigeons. Not really particularly interested in pigeons, but they will be detected for sure. Okay. Okay, right. I think that's enough for birds. And for cats, I have plenty. I have this cat. See? Yeah, I can take a picture of them. This one. And just make sure VLC. Right. Okay. Right. So now I can open my file. Okay, so I have some pictures of cats now. Okay. So we have a cat. Yeah. And this one, maybe I deleted because it's too difficult to detect. And this one as well. I'm not looking for hidden cats. I want to see one in plain view. So okay, I have some cats here, and I think I'm going to finish for now because it's a bit late already, and I might spend more time tomorrow collecting more test data, but for now I think this is good enough. Okay, I haven't done this is like the first live stream I've done like in a couple of years, so yeah, anyway, this is just to get me started. I'm hoping to do a lot more of this. If you think this live stream useful and you want to see more of them, yeah, don't forget to click the like button, and I hope to see you again soon in the future. Happy coding!